All right. The second example in skill number 4 is more the same. It's pretty similar, but there are more unit conversions worked into it. Right. And so part of this is just coming from what would be sort of the typical units that we would have for each of these measurements. Let me sort of read us through the problem and then I'll sort of talk us through it. So if you have a tire with a diameter of 22 inches, it rotates at 6.8 revolutions per second. So we can do a couple things, right? So this is my diameter, 22 inches. This is my angular speed, right? My omega, again, looks like kind of like a W, 6.8. So that's rotations per second, right? So the time units there obviously matter. So find the linear speed of the car in miles per hour, right? So this is a little bit more realistic in terms of like what are the units that we would normally sort of have for this situation. Maybe you would have RPMs if you're sort of, I know you get engine RPMs and those are a little bit different from what you get at the wheel. But let's just say for sake of argument, we've got sort of revolutions per second, sort of, almost 7 rotations per second. We've measured somehow. We know the tire is 22 inches because we can just measure it. We're trying to figure out how fast the car would be traveling in miles per hour, right? That would be our sort of typical linear speed, right? So find the V. So first things first, I know for sure that I'm going to need my circumference sort of regardless. So pi times my diameter, pi times 22. Just using our regular 3.14, right? This is 22 inches, so I get 69.115 inches. So that's my circumference. And I'm going to keep talking about the units as we go here, right? So that's my circumference. It's in inches. I know I'm going to need to end up in miles, so I'm obviously going to have to do a conversion from sort of inches to feet to miles at some point. Don't do it yet, right? You don't want to sort of get your circumference in miles because it would just be a ridiculously small number. It would be this very tiny decimal. So don't do that yet. Just sort of save it all for afterwards. If we find the linear speed by just sort of doing the multiplication first, right? So if I've got my circumference is 69.115 inches per revolution, right? Times my omega, 6.8 revolutions per second. We have the same sort of cancellation from the last one, revolutions per revolution. And so what this is going to give me is an answer V, and it's going to be in inches per second, right? If I just sort of follow along, 6.8 times 69.115. This would be sort of inches on top per over seconds on the bottom. So that would be 469.98. Effectively 470, right? But I sort of keep those decimals going for now. So that is a linear speed, right? 469.98 inches per second. It just is not really in a unit that we can imagine very well. You say, okay, so 469.98 inches, 470 inches. Like I don't have any good sense at all off the top of my head how big of a distance that is to sort of imagine covering it in a second. It kind of doesn't mean anything. Miles per hour is sort of what we have in our head, right, as a speed unit. It's kind of what we could sort of reference. So that's what we're after. So what happens here is this problem really becomes a unit conversion problem, right? I mean, this is just a pretty quick multiplication to get us to here. And so then the question is, okay, I need to get from this into miles per hour. So I need to convert inches to miles, and I need to convert from seconds to hours, right? I want to go from inches per second to miles per hour. So a couple of these we have, you can see the one that's here, 3,600 seconds per hour. The connection here, right, is 60 seconds for every 1 minute and 60 minutes for every 1 hour. So if you took those two and multiplied them together, that would be 60 times 60, 3,600, right? 3,600 seconds per 1 hour. That's where this value is coming from. We can sort of just jump to it. that would cancel, right, seconds for seconds. This is MA 105 style, right, where you're trying to sort of set up these unit conversions by setting up sort of a numerator and a denominator version of the same units to cancel fraction style, and you have your sort of new units, your kind of goal units left over, right? So this would cancel seconds with seconds, and it would leave me in hours. Then I would need to do, right, so inches, right? I need to go from inches to feet, and then feet to miles. So I have 1 foot for every 12 inches. So this ends up being sort of a division by 12. That would be sort of inches per inches, right? That would leave me in feet. I'm trying to go not just to feet per hour, but miles per hour. So then I need to do a second round, which is sort of feet per mile. 12 inches a foot is pretty memorable. I would say most people probably remember that off the top of their heads. Feet per mile is a little bit less memorable. It's 5,280 feet for every mile. So we'll set that guy up, and then we cancel feet for feet. So this is kind of a 2-for-1, right? We need to do these 2 unit conversions. That would leave me in miles per hour, right? Everything else has been canceled away. And so the math here, right? So this is 469.98. What are we doing? Well, this is times 3,600. And then it's divide by 12 times 5280, right? So the 12 and the 5280 are on the bottom. The 3,600 is up top. So those all kind of balance each other out. They sort of work against each other. I'm going to shift this up. I'll just show you the calculation on the number cruncher here really quick. It looks like we should end up at 26.7. So what have we got? 469.98 times 3,600, right? So that bumps it way up. This is, up in the 1 millions, but that would have just been inches per hour. So that is sort of to be expected. If I do it divide by 12, that gets me part of the way there. Divide by 5,280. Okay, that gets me down to 703. 26.7 is a perfectly reasonable answer there. So this is really a unit conversion problem more than anything else. I mean, obviously it has, our linear speed is the circumference times these rotations. I mean, that's the setup, the initial setup. But it really becomes a unit conversion problem more than anything else. I'll run a second example. I'll just sort of pull one from the exercises here. So I'm going to pull number 8. Very similar type of question, but just sort of asked in a little bit of a different way. So a car with 19-inch tires is rotating at 1,120 RPM, right? So rotations per minute now. So that car is traveling on a road with a speed limit of 55. So is the car speeding? So let's look at this on its own. So I've got the information here, right? So the tires are 19 inches in diameter. The angular speed, 1120 RPM, right? So that's rotations per minute. My speed limit is 55 miles per hour. And so the question is, I need to essentially find my linear speed and determine whether or not I'm speeding. If I'm sort of have these sized tires and they're sort of rotating at this speed. So a couple things, right? I need my circumference for sure. That's going to be pi times my diameter. So that's 3.14 times 19 inches. Let's see what we got. 59.66, that's inches. The units here again, extremely important. So we'll keep them going. My linear speed, my velocity should be the circumference times the rotations, right? So we'll mark these with my units. 59.66 inches is my circumference times my rotations. So this is 1120, right? Rotations per minute. If we multiply this, it's going to get me my speed. So 59.66 times 1120. So 66,819.2. what are my units? So that's inches per minute. So that's a linear speed, right? That is a speed, but the units are not what I'm after. So that's inches per minute. What I want is miles per hour. So I need to do a conversion there. So we'll set it up. So 66,819.2. So I'll do inches for every 1 minute. So I'll just set up my fractions. So this is again kind of 105 style. You're really just doing various sort of divisions and multiplications here, but I think writing the full thing out with the units as fractions using the different ratios is, I think it's best. I think it honestly, it helps me a lot to sort of keep things straight. So what did we say? So we want to go inches to miles, right? So I need 12 inches for every 1 foot. I need 5,280 feet for every mile, right? So that would be sort of a divide by 12 and a divide by 5,280. That would get me from inches to miles. And I need to do a time conversion too, right? Because I'm trying to go from per minute to per hour. So I want 1 hour on the bottom, and the conversion rate, right, is 60 minutes. Cam got away from me a little bit there. 60 minutes per hour. So this is going to be, right, minutes per minutes, inches per inches, feet per feet, and I would be left with miles per hour. I just need to actually sort of do the calculations here. So what am I going to get? So I've still got my nice 66,819.2. So this would be divide by 12. I'll kind of just go in order, right? So divide by 12, divide by 5,280. So that would get me miles per minute. So that's 1.05, 45, yada, 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 1.05, let's say, miles per minute times 60, right? Times the 60 up top is going to be 63.27, 63.3 miles per hour. So it's just a lot of unit conversions, right? So getting the initial thing, just sort of doing the initial setup is pretty straightforward. It's just a quick multiplication. You need your circumference, but then doing the unit conversions to actually sort of get it from what would be the typical sort of size units, distance units for, the size of a tire. You're not going to measure the size of a tire in miles. And sort of rotations per minute, you're probably not measuring rotations per hour, right? So as these things sort of multiply out and scale up, you get different sort of values. And in this case, we end up going 63.3 miles per hour. What was the original question? Well, if the speed limit is 55, are we speeding? The answer here is yes, right? So we're going we're going sort of faster than 55. So we are speeding. Now, are we going to get a ticket if we're going 63 and a 55? I don't know. Probably depends. Depends a little bit on whoever's clocking us, and do we need some extra bucks this month or what? But technically, by the law, by the sort of by the numbers, we are speeding, and we are very sorry about that.